This section introduces the idea of an oblique or slant asymptote. This occurs when we do not have a horizontal asymptote, as in the example that I have in front of you here. If you notice, the degree in the numerator is greater than the degree of the denominator, and we have always put in the past that there was no horizontal, which is still true, but what we do have is a different type of asymptote called a slant, and you find it by performing division on the polynomial. Now, the book said that you use long division, which is true, but in this case, our divisor or denominator is linear, so we can use synthetic division for this. So we're going to set up our synthetic division and then find what the polynomial is when we get the result of the synthetic division. And when we do that, we get this polynomial, which is linear. So y equals x minus 4. Now if you notice, the 11, we ignore that. And the reason we ignore that is because it will not affect the shape of the graph. So we don't even include it. So on the graph, we would see that there's a break where x equals 4. So I'll show that on the calculator. So when I go under y equals, I'll put in our function, which is x squared minus 2x plus 3 in the numerator, and then the denominator is x plus 2. And then I will also put in our slant asymptote, which is x minus 4. And when I look at the graph, what you'll see is that the function bends around that line, and I'm going to have to adjust the window so we can see the whole thing, I think. So there's the slant asymptote. Yes, let me adjust the y values of the window. So let me zoom out a little bit here for the y's. So we'll go to negative 50, and we'll count by tens. And when we look at the graph, we'll see the other piece and how it bends around the slant asymptote. As you can see, it sits right along the edge of it. The function's still headed towards negative and positive infinity, but it bends around the asymptote.